Hello everyone. Today we will go through assignment number 3. So the question we asked you was about disjunction, conjunction, and also the Boolean multiplication, as you can see here. So let's go through them one by one. So for this disjunction, in order to deal with that, it's very similar to subtraction or addition for different matrices. Like, for example, if I want to add this one to the other element of B, it should be exactly from the same position. So it's pretty easy. And for disjunction, this is the same situation. So this is my matrix. What should be the size of it? From the beginning, I should understand it. So this one has 3 rows and 3 columns. So this is a 3 by 3 matrix. And if I want to apply disjunction and compare it to another matrix, it should have the same size. So it should be 3 by 3 too. Otherwise, we cannot do that. So it means that at the end, I will have a 3 by 3 matrix. So for example, for this one, for the first element, I should compare 1 with 0. So 1, disjunction, 0. Okay, and I can apply it for all of them. So it should have 3 columns and 3 rows, right? For example, let's say I want to calculate this one. Again, the same. It is disjunction of 1 and 0. So when you provide the solution, first show them one by one like this, and at the end show the final answer. Okay, what's the disjunction of 1 and 0? It means that one of them at least should be 1. If it's the case, then this is 1. If both of them are 0, like this case, so 0, disjunction 0, it will give you 0 for this position. Now you may say, for example, it's not easy for me to type in a matrix. By using math type, it's possible, but let's say you cannot use math type in Word. Then there is another way you can represent it. So if you say this one, I can call it, for example, M. So the result, I will save it in the matrix M. Then, for example, M contains 9 elements inside it. It's a 3 by 3. And each one of the elements I can show like M11. This is related to the first row and first column element. So for your calculation, you can do this, like write M11 and show the calculation like 1, disjunction 0. This is also acceptable if you do that. But if you want to do type it in this method, you should first show that this is related to your matrix and it should be well defined. You should specify the size of your matrix. For example, say M is 3 by 3 and Mij are the elements of this matrix. If you do that, then it's okay. You can also type it like that. Otherwise, if you can use math type or you want to write it manually and take a picture of it with good quality, you can show it also in matrix form, which is easier, I guess. Okay, in terms of conjunction. So this is very similar, the operation comparing to disjunction, but the thing is that both of them should be at the same time 1, so that we receive 1 at the final answer. It means that if I want to represent it with M again, like M11 is equal to 1, and sometimes we call conjunction and 1 and 0. So what's the answer of this one? This is equal to 0 because both of them should be 1 in order to receive 1 as the final answer. For example, in this case, we can see both of them are 1. So for 3, we will have 1 conjunction 1, it is equal to 1. So this is also possible to show me all the elements like this, but don't forget to provide all the answers for the all the elements for the target matrix. And you should give it a name. For example, I gave it M. You can give it any name you like. All right, for the last one, now we have this Boolean multiplication. It's different from Cartesian one. In order to deal with that, it has some similarity with Cartesian one. As you know, in order to find my final answer, I should consider element by element like this. For the element of M11, then in that case, I should consider the first row from the first matrix and first column from the second matrix. So that's the way we dealt with that in the Cartesian product as well. When we talk about this Boolean product, then in that case, instead of disjunction, we will have, instead of plus, we will have disjunction, and instead of multiplication, we will have conjunction. So what we will have here is 1. Instead of multiplication, I will have conjunction. Then instead of plus, instead of getting the summation of all of these components, I will have disjunction. So you see, it's pretty easy. Instead of plus and multiplication, just replace them with these notations, and that would be easy to calculate. So for the second one, 0 with 1. So 0, 1. Again, 1 with 1. So 1, 1. And what's the final answer? In order to provide the final answer, don't rush. One by one, show the complete solution. So 0 or 0 or 1. So as you can see, since we have this disjunction, then even if one of them is 1, the final answer will be 1. And what would be the size of our target matrix, by the way? This is 3 by 3. This one is 3 by 3. So it's pretty easy to understand that the final answer we will have as 3 by 3. So I don't know if I need to explain about the other part because it's pretty straightforward, but let me take your questions after that. If you have any questions, please let me know. And in the final exam, by the way, don't forget, for example, if we have the other size, like instead of 3 by 3, assume that I had 2 by 3. And then I couldn't have this multiplication, right? So we should be careful about these things. And also the other thing I want to mention is that assume that you have other matrices like C is 2 by 2, D is 2 by 2, and I want to insert these matrices inside one matrix and represent my new matrix. Let's call it M. Then inside the elements of M, I can consider, for example, for this part C, for this part D, this one D, this one C. I can also show matrices like that. It's a kind of representation of matrices. So if I ask you what's the size of M, what would you say? Like here, this is 2 by 2, again 2 by 2, another one here. In order to find out about the sizes, it's pretty easy. Just consider, for example, this first column. Here I have 2 rows here. 2 other rows are added to it, so I will have 4 rows overall for M. And for the column, the same situation. Consider the first row, and you can see it has 2 columns here and 2 other columns here. So this is a 4 by 4 matrix. So it's a kind of representation of matrices as well, that you have some matrices and you can insert it in other matrices, which is very helpful. And in mathematics, if the sizes don't match, like for example, here I have 2 by 2, here I will have again 2 by 2. I define another matrix, let's say this is 2 by 3, and again this one is 2 by 2. Then it will be problematic for us, because now we mentioned about the third column here, but we don't have any elements here for D to represent that. It means that I have 2 columns here for C, which is okay. Again, I will have 2 columns for D. Fine, we will have elements for them. But for this one, I don't have any information. Again, the same situation for the second row. But as you can see for M, it continues, and then it will be problematic. So what we do, let me take the questions after that. We will go through all of them. So what we do, in computer science, we consider 0. Whenever you don't have any information about the cell, we consider 0. But if we are talking about mathematics reasoning, then in that case, we cannot define such matrices. And in the exams that we are dealing with for this course, we are considering mathematical reasoning, okay? So if such cases happen, just explain that it's not possible because I don't have information about these 2 cells. Okay, guys, let me take the questions if you have any. Then we will go through the lecture on Friday.